Hello, my name is BaekKyu from University, South Korea. Today I'd like to introduce my new concept of the land robot, which is legway. The legway is a wheel leg transforming robot. The reason to develop this legway is because most legged robot is slower than the wheeled robot. So to overcome this drawback, some researchers attach the wheel at the end of the leg of the legged robot. But the legways, the mechanics of the legways are a little different from them. The mechanism of the legway have the forward linkage system, and also legway has the foot and wheel together. So using the forward linkage mechanism, the legway transforms its mode among the station mode and leg mode and wheel mode. So I'd like to explain more detail. In the wheel mode, the legway seems like the inline skater. So in the wheel mode, legway can make active suspension, also the dynamic turning motion. Also legway can go any uneven terrain using the change in the height of the leg. Also legway can make rapid start and stop motion using the dynamic balance. Also legway can easily avoid the obstacles using the leg motion. In the walk motion or leg motion, legway can go any place by foot, like a normal bipedal robot. So as you see in the picture, legway can go the stairs or overcome the obstacles. Also, in the station mode, legway can fix on the ground using the 2 feet and 2 wheels. So it can have some people do some tests. So anyway, through the kinematic analysis, I decide the design parameters. So this is the shape of the legway. The length of the link is about 40 centimeters, so it seems like the cube. And the total degree of freedom is the 14 because it has the two wheels. In this case, I use R&D motors from China because it is cheap and reliable. And the total mass of the legway is less than 40 kilograms. And here is the control framework. So in the control framework, I have two the controllers. One is for the wheel driving, and the other one is for the rapid locomotion. In the working controllers, I use two different MPC controllers. One MPC is to generate the CO and trajectory like the previous control. And in the second MPC, I generate the ground reaction force like normal recent the algorithms for the quadrupedal robot. And in the wheel mode, I use conventional control algorithm for the Segway type robot. In this case, I use LQR method. And finally, I conducted several simulations to verify the algorithm in Gazebo system. This is the first simulation, and as you see in the video, it is a mode change simulation. As you see in the video, it changed the mode from the station mode to the wheel mode, or you can change it to the leg mode or something like that. Yes, in the second simulation, I conduct the wheel mode of the operation. As you see in the video, the legway can go uneven terrain very stably. Also, in the second video, the legway can make a dynamic turning motion using the keeping the balance. In the third simulation, the leg weight can go any places by the feet. So like normal, the bipedal robot, the leg weight can go any flat places, also can go the stairs. So through the simulation, I realized that the algorithm is verified, the validate. The simulations, the real experiments are totally different. So nowadays, I focusing on realizing my algorithm to the real robot. So till now, I realized two experiments. The first one is transforming the mode from the station mode to the leg mode, and second video show the wheel balance like a Segway. So anyway, I'm still struggling to realize the algorithm to the real robot. So I really want to show our further result in the next conference. Thank you for listening.
When you showed the animation going up the stairs, it looked like the wheel got fairly low. Is there a limit on like how steep the stairs can be?
Actually, I need to adjust the design of the robot to avoid the hit the stairs, but that will be designed next time. Yes.
Why doesn't your controller go crazy when you switch into, you're switching these contact modes, and you're not doing it in a soft way?
I'm not sure the controller during the switching the mode, but until now I use just heuristic the approaches, but I'm not sure. But I will handle the more the detailed controller the algorithm, but not yet. Yes.
So I'm wondering, it's a pretty cool design of a robot with the movability of those contact points at the wheel mode in particular is what I'm thinking of, right? I'm wondering, have you thought about the interesting kind of movements or strange mechanics you might be able to put into it by having them not just like a standard parallel wheel, common axis, differential drive robot? Like put one out in front or something?
That is the point, but this is the initial stage to build the leg weight, so I need to optimize the design. Or also, in this case, I use the chip, the RD motor. So because of that, the design of the robot is a little big. But if I use another types of the motors or something like the maximum motors, I can adjust the size of the system, and then I can avoid the hitting the ground by the wheel. But I will think about it. Yes.
From the design parameters, I don't remember if you mentioned like the distance between the foot and the wheel. Was that one of the design
The
parameters?
40 centimeters.
Do you have a reasoning for that? Like why so far apart? Why not?
Because of the motor. Yeah. I can solve that problem. It's done. Thank you.